Hi everyone, and let's continue our discussion last time about circle as a conic section. Remember that in the circle, last time when we discussed about circles, we actually learned about how to find the standard form of it when given the center and the radius, you know? So, yes, we discussed this. I actually erased the solution here, actually, but I did solve this one. So you can just watch the previous video, okay, about this, yeah, this video. So here, what we're going to do is we're going to continue because here, these problems are different from those we solved last time. Okay, we know how to find the standard form at least of the circle when we're given the center and the radius. However, in this case, center, radius, or both are indirectly given. They're not given here, basically. All right. And let's just say, right, I showed to you, we only have the given, which are endpoints of diameter. Then here, we have a given, which is, yeah, that's a good thing. We have a center, but we have an endpoint. You know what I mean? So that means radius here is not given. But still, okay, what I'm trying to point out here is that in these problems, circle, no, center, radius, or both are not given. So how are we going to find the standard form of the circle? All right, so let's proceed. In here, we have the endpoints of diameter. Okay, we have -1, -3, 5, -3. Okay, so in this case, I want you to visualize a problem. Okay, I have a circle here, and we have a given center. Then let's just say I have a given radius. Okay. Now here's the thing. I have a center here, which is here, yes, and have a radius. Now let's just say I would like to add another radius, and that radius will make a straight line here. Okay, right? I have a radius from there to there. Now I'll make another radius opposite to that one. Okay, so that I will have one whole straight line. So in this case, I'll be having like this. Okay. So here I have one whole straight line. So if you're going to observe that you can actually form one whole straight line just by connecting two radii. Okay. Now, in this case, what of it? Okay. Now that I show to you what is this even due to the problem. If you have one whole straight line like this, okay, and it passes through the center, okay, it passes through the center, okay, this line is what you call the diameter. Okay, diameter is basically a chord that passes through the center, okay, a line inside of the circle that passes through the center, okay, and you can find the length of the diameter by using the formula 2 times r or 2 times radius. So basically, the length of these two radii will give you the total length of the diameter. So in this case, what are we going to do then? All right. And especially the fact that, okay, I showed to you what diameter is. So how is this even related to the problem? Now, here's the thing, right? We have a given endpoints of diameter. So that means corners of the diameter are, for example, zero point 0.1 and zero point 0.2. Okay? These are like the endpoints of your diameter. And then let's go back to the main problem. We are looking for the center and radius. Because without the center and radius, we cannot find the standard form. Remember that in a standard form, if you remember its formula, it's the square of x minus h. Wait, there you go. Plus the square of y minus k is equal to r squared. Okay? Remember, we are going to find the standard form. And for us to find the standard form, we need the center and radius. Without these two, it's impossible for us to find the standard form. So how? Now, here's the thing. Okay. Let's just say we want to find the radius. Okay? We want to find the radius. So I want to start finding the radius. In here, what you're going to do is you're going to first get the length of the distance between 2 points or two endpoints of the diameter. Like, what's the total length here? Okay? Why, if you're asking me? In here, once you found your total length of the diameter, you can immediately find your radius. Remember, okay, diameter is twice the radius. So if we have a given diameter, like for example, I have 8, okay, 8 units long. So here, I can find my radius. I can simply divide both sides by 2, and that would be the results. You know what I mean? Now, okay, that is a solid plan, but how are we going to find the length of the diameter? So here, what we're going to do is we will use the distance formula. So this is the distance formula is x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1, y sub 2 minus y sub 1 squared. Remember that these x sub 1, x sub 2 are from the endpoints itself. So if you have first endpoint, you will represent this endpoint as x sub 1, y sub 1, because it's the first endpoint. While this one, the second endpoint, will represent this as x sub 2, y sub 2. Okay, since it represents the second endpoint. So here, you can get the distance of the diameter, like that, I mean the length of the diameter, by using distance formula. Then after that, once you found the diameter, you divide it by 2, you get your radius. That's it. Okay, you need this formula for you to find the radius. Now, how about the center? Okay, the center. How are you going to find the center? So the center is easy because all you need to do is use the midpoint formula. Okay, for you to use the midpoint formula, okay, you will be familiar with this. Okay, y sub x sub 1 plus x sub 2 all over 2, comma, y sub 1 plus y sub 2 all over 2. Okay, this is the formula for midpoint. All right, now, why use midpoint formula? Because here, what do you call this one? Let's just say we have point 1 and point 2, right? And then, okay, let's just say you're curious about the distance between the two. But let's just say you want to know the middle point. Like, what's the middle point of these 2 points? If I have point 1 here, point 2 here, okay, now we want to know what's the middle point. Like halfway to the next point, what's the middle point? Okay, the median, or we call it the middle point whatsoever. So what's the middle point? So in the middle point, you're going to use this one. And why is it related into the center? Because you see, once you have the two endpoints of the diameter, and then let's just say you want to know like the distance between the two endpoints of diameter, midway is your center. Okay. So if this tells you, like for example, this tells you the whole length of your diameter. So the middle part of your diameter is actually your center. So therefore, for us to find the center, you need to use the midpoint formula. Okay? So now, I hope you get the idea because that is what we're going to do in this problem. Okay? So without further ado, let's now solve the problem here. Okay? Let me just erase this one. Except the formula though, because we're going to need it. Okay. So, I'm just gonna put it here. Right, there we go. So let's start first by finding the radius, okay? So since we have given endpoints of diameter, so what we're going to do is we're going to use distance formula, okay? So let's solve. We have two endpoints here. This is your point 1. So we will have x sub 1, y sub 1. Then here we have your second point. So we will have x sub 2, y sub 2 here. So let's directly substitute them in the formula. Your x sub 2 is 5 minus x sub 1 is negative 1 squared plus your y sub 2 is negative 3 minus your y sub 1 negative 3. Okay, so now we will solve it. 5 minus negative 1. So minus negative, this would become 5 plus 1. Here we have similarly negative minus negative. So that means we will have plus 3. There you go. Then let's combine everything. So 5 plus 1, you will have 6. So 6 squared. Negative 3 plus 3, that will be just 0. So you have plus 0 squared. Or you can disregard the 0 and you will have 6 squared instead. So here, if you're going to square root a one whole term that has a squared, you can just simply cancel this one and you will have 6 as a result. Okay? Because if you're going to square root a one whole term and then it has a squared, you can just cancel them both and you can leave this as a. All right. So therefore, your length of diameter is 6 units long. Okay, that is your diameter. However, we're not done yet because again, we're not interested in finding the diameter, but rather the radius. Okay, we are looking for the radius. So therefore, since our diameter is 6 units long, we're going to substitute it here in this formula. Okay, so that we can find the radius. So here in this case, we have 6 is equal to 2r. So to find the radius, we're going to divide both sides by 2, and we will have 3 as the length of radius. So therefore, we found our length of radius, which is 3 units long. Okay, so your radius here is 3 units long. Okay, so we're done. We're good. Okay, we're good. Now what's next? We're going to find the center. So finding the center, just simply use this formula. Okay, so let's find the center. Okay, let me replace m of xy as center. Okay, since we're looking for the center by using mid formula, so that means I can just simply change here m of xy as center. Okay, so with that, let's now substitute. So your x sub 1, once again, it's negative 1, plus x sub 2 is 5 all over 2, comma y sub 1 is negative 3, plus y sub 2 is also negative 3. Okay, so now we will combine everything. So negative 1 plus 5 is 4, positively. Negative 3 plus negative 3, so plus minus. So positive times negative, you will get negative. Okay, so you will get negative. So in this case, instead of plus negative 3, you will get minus 3. All right? So negative 3 minus 3 will give you negative 6 all over 2. Then here, 4 all over 2, it's just the same as 4 divided by 2, so you have 2. Negative 6 divided by 2 is negative 3. Okay, and that is your answer for finding the center. So you found the center. Okay, your center is 2, negative 3. That's it. And now, in this case, we found your center in radius. We can now use this formula to find the standard form of the circle. Okay. So, the fact that we have center as 2, negative 3, and radius as 3, we will substitute it here. Your h is once again is on the left side of the pair, so it's 2, and your k is at negative 3. So therefore, in this case, we will have x minus your h, 2, squared plus y minus your k, negative 3 squared. Then your r, which is radius, 3, so 3 squared. Okay, remember that we have negative, negative, so that means we will get positive. So therefore, we will have y plus 3 squared is equal to 9. And that is your answer for the problem, for this problem. That's it. Right? That is basically how you'll solve it. Right? So yeah, that is all. Now let's proceed to the last problem. How about this one? Okay. Now here, I want you to visualize a problem as well. Okay. So again, we have the center and we have a given endpoint. Suppose that the endpoint is here. Okay, the endpoint is here. Let's just say point 1, okay, or point P rather, since we only have given one endpoint. So here, we have the center and an endpoint. And then you're looking for the standard form and general form of the circle. Now, how are we going to do that? Okay, center is given, but the radius is not. So we need to find the radius. Now, let me tell you again, center is given, endpoint is given. So in that case, we can actually find the radius, you know, because if we have an endpoint and a center, getting the distance between the two will be the length of a radius. You know what I mean? Like we have the center, we have the endpoint. So get the distance between the two, you will have in fact a radius. You know what I mean? So how are we going to get the length of the radius? So we will use the distance formula. Okay? The distance between the center and an endpoint will be will be the length of your radius. Okay? So in that case, the length of your radius would be, let's just copy the formula here of the radius. Let me just put it here. Formula, the distance formula. Wait, here. There we go. Okay. So the length of your radius is just simply the use of the distance formula in this problem. Okay. Now here, you're going to pick though which one is your first endpoint, which one is your second point. So for me, my first point would be the center, and my second point would be the endpoint. So in that case, your x sub 1 is 1, your y sub 1 is negative 3, x sub 2 is negative 3, and your y sub 2 is negative 5. So with that, we can substitute it here. So the square root of x sub 2 is negative 3, minus x sub 1 is 1 squared, plus your y sub 2 is negative 5, minus your y sub 1, negative 3. Okay, so here, negative 1 minus 1 is negative 4 squared. Plus here, we have minus negative, so that means we will have plus 3 instead. So negative 5 plus 3 squared. So here, we can direct them, we can, what do you call this one? Combine them. Negative 4 squared will basically give you 16. Plus here we have negative 5 plus 3. So 5, 4, 3, 5, 4, 3, 2. So negative 2 squared. And negative 2 squared is simply as 4. All right. So here you will have square root of uh, 16 plus 4, 20. That's it. Or you can simplify this because this is just the same as 2 square root of 5. How do I know that? Well, 20 is just the same as 4 times 5, right? And here's the thing. I can have, instead of square root of 4 times 5, I will have square root of 4 times square root of 5. That's actually is valid because according to the law of exponent or law of radical, uh, law of radical, if you have a root of a times b, or it could be square root or cube root, you will have n root of a times n root of b. You know what I mean? So therefore, instead of square root of 4 times 5, we can have square root of 4 times square root of 5. And the fact that we have square root of 4 given here, so this is just the same as 2. And that's it. Okay. So that is the length of your radius. Okay, no need to divide 2, okay? I mean, actually, we're not going to divide it by 2 because here, we're looking for the distance between the center and an endpoint. An endpoint is basically a point on a corner of the curve. So get the distance between the two, you will have the length of the radius. So don't divide it by 2, okay? So with that being said, we can now find the standard form, all right? Let me just erase this, okay? So here in this case, okay, you have a, oh, there you go. You have your radius as 2 square root of 5. Now, we can now substitute it in our standard form. So, remember, in the center, okay, your h is on the left, your k is on the right. So, substituting it here, you will have x minus your h, 1 squared, plus y minus your k, negative 3 squared. And then here, your radius, you're going to square 2 square root of 5. Okay, so let's just combine them everything. Minus negative, so that means you will have plus 3 squared. Okay, here, square of 2 square root of 5. Okay, this is just the same as 2 squared times the square root of square root of 5. So 2 squared is 4 times square root of square root of 5. In here, if you're going to square a square root, the square root and square will cancel out. So what's left is the base, which is 5. So 4 times 5 is 20. So therefore, the result overall is 20. So this is your standard form. Okay, we're good at here. Now, what are we going to do now? Next is find the general form. So here, the first step here is that for you to find a general form, given the fact that you have a standard form, you have to expand them. So I'll go direct to the point here. I'm not going to explain how, okay? Because I already taught you like multiple times on how would you expand, okay? So here, the expansion of these two squared binomials are x squared minus 2x plus 1 here plus the square of the expansion of square of y plus 3, you will get y squared plus 6y plus 9 is equal to 20. That's it. So everything is expanded, no more parentheses. Then we're going to group all terms on the left side. So let me just copy this. Transpose 20 to the left. So it will become negative 20 is equal to 20 is equal to 0. Then here we're going to combine like terms. So the only terms that have like terms are constant terms. We have 1, 9, and negative 20. So adding them all together will give you 1 plus 9, 10 minus 20, negative 10. Okay? So you will have x squared minus 2x plus y squared plus 6y minus 10. 1 plus 9, 10 minus 20, negative 10. Okay. Then lastly, you have to rearrange them according to their exponent. And it should be from highest exponent to the lowest exponent. So therefore, we will have x squared plus y squared minus 2x plus 6y minus 10 is equal to 0. And that is your final answer. And that is all, guys. All right. Maybe I'll be having some another problems about these stuff, like the center is indirectly given, but the radius is given, or let me take a look. Like basically, maybe in the next video, maybe I'm going to upload some videos that we're told to find the standard form, at least when we're given the endpoints of a diameter or endpoint of a circle, so on and so forth. Or if not, then I'm just going to upload a practice video because we're done talking about how to graph them, especially about these. So maybe practice video is the next video I'm going to upload. All right. So that is all, guys. And thank you guys for watching this video. See you soon.